Good morning. My name is Michał Bessler. I'm machine vision engineer in Adaptive Vision team. During this presentation, I would like to talk with you about the standards of communication and its importance in the modern Factory 4.0 solutions. As we know, that now we are encountering the fourth industrial revolution. The Factory 4.0 is a very broad concept. However, one of its main pillars of operation is the complete networkization of the production on the factory floor. We are encountering both horizontal as well as vertical integration. And during this presentation, we will see how we can combine that with our machine vision solutions. Generally speaking, at the beginning of this presentation, we'll be talking about the importance of communication standards. We'll see the requirements, rather atypical, and later the emerging. Then we'll take a look at the available protocols in Adaptive Vision Studio and how we can use them for inside our application. Finally, in the second part of this presentation, we'll be talking and I will present you an application created inside Adaptive Vision Studio and communicating with Siemens PLC over the Profinet protocol. Okay, let's get started. So, why do we need a communication between our vision system and the neighboring devices? First of all, one of the very important requirements is simple sending the inspection results. Without any information from the vision system, we'll not be able to, for example, control the rejector. So we would like to have a full, let's say, synergy of the vision system and the neighboring devices. Another requirement is related to the, for example, changing inspection recipe. Currently, on one production line, we can produce a number of different items. And for each item, we need a different inspection routine. For such situation, we would like to adapt the program running in our vision system so that it can read and verify the objects reliably. Another rather atypical requirement is related to the robot navigation. Let's see about such an example. We have got a camera mounted above the conveyor belt, and we would like to first we would like to localize and later send information about the picking coordinates for our robot. For such application, the protocol for exchanging data is crucial, is very important for that. Okay, that's just a few examples selected out of probably hundreds different, and it all depends on your application and on your requirements. Then let's see what are the emerging requirements mainly related with the Industry 4.0. First of all, we would like to use information from our vision system as a source of data for predictive maintenance. The vision system is like an eyes for the producing machines. And we can not only measure, for example, the object dimensions, but we can also evaluate the quality of its how it was produced. Let's imagine a milling process. We can, of course, measure whether the product has been prepared according to the customer requirement, but we can also verify the quality of the edges. We can look for any scratches on the surfaces, because each such information can give us some indication that, for example, a production tool, is deteriorating and we should replace it soon. So we can use a vision system not only to measure and to give a pass-fail information, but we can also use it as a source of many other parameters of our producted component. Then we can use it for tracking production deviations. We can, for example, try to mount a camera above the production line, and by subtracting the consecutive frames, look for some deviations from the let's say typical situation. Using such a simple technique, we are able to verify whether on our production any anomalies appears. Then another requirement very closely related to the Industry 4.0 is related to accessing production details anywhere. First, it can be very simple, like sending data or sending the inspection result to some FTP to more convenient access. But it can be also related to accessing data using a smartphone. Finally, we can use a vision system and the information gathered with that for the productivity monitoring. We can see how many pieces each shift produced, and using that we can, let's say, adjust the production conditions so that we can achieve a maximal performance. Okay, once again, it's just a subset of all possibilities. So once we get information when do we need protocols of communication, now let's see what protocols are available inside Adaptive Vision. First of all, we can use a industrial protocol, a Profinet, as well as Ethernet IP. Profinet is available for quite a long time, and the Ethernet IP will be available very, very soon. Both of these protocols are standard and, let's say, typical for many factories. Profinet is mainly related to the Siemens, and once you spot a Siemens PLC on the production line, you can be sure that the devices there are communicating using this protocol. Ethernet IP is rather connected with the Allen Bradley company and Rockwell Automation brand. So once again, once you see a Allen Bradley PLC on the factory field, you can be sure that the Ethernet IP is a standard of communication there. Inside Adaptive Vision, we are using a Killshare devices as a network adapters. That's a card, the network card, and it comes in many different sizes and shapes. There are available PCI cards, mini PCI cards, PCI Express, mini PCI Express, M2 cards. So I'm sure that everyone will find a best card suiting for the needs and for the hardware which you have on your inspection booth. Okay, and apart from these protocols, we have got also a Modbus TCP and let's say a traditional or standard TCP IP. It always depends on what you have got on your production line, what is a standard there. From our point of view or perspective, working using a Profinet or Ethernet IP is much easier and much more reliable than using just a raw TCP IP. However, we also see applications where it is very useful and important. So select the best protocol which suits, select a protocol which suits your requirements best. Okay, once we cover the available protocols and when or where do we need them, now let's see a practical example with Adaptive Vision Studio and Siemens PLC. As I mentioned before, I will be using a communication over the Profinet. In fact, in this situation, a PLC will be a master and we, as Adaptive Vision, will be connecting as a slave device. Okay, give me a second. I will switch between the applications. Okay, here we have got our application. This application has 3 worker tasks. So we have got 3 routines executed in parallel. We have got a main. Here we perform the image acquisition, then calibration or rectification of image, and later the inspection and sending results. We are sending results to the second worker task, which is for the communication. So here we are reading data from PLC and sending the inspection results. Finally, in the third worker task, we have got, I call it an offline inspection, and we'll use it later to see how the image analysis routine works. Okay, so let's start with the communication worker task. At the main beginning, in the initialize section, I have to open the Profinet connection, and then I'm reading information about the available slots. I will take it to the preview. So, as you can see, in this application, I created 7 slots. When I now switch to the TIA portal, you will see that exactly the same number of slots and size of data we have got on our, let's say, PLC side. The only one difference is that something which is as a incoming or in direction on the Adaptive Vision side, on the PLC side, on the TIA portal, is an outgoing type of data. So something which is going out from PLC is coming in to Adaptive Vision. And it exactly looks for the opposite direction. So something which is going out from the Adaptive Vision is an input to the PLC. As you can see, I have got 3 inputs and 4 outputs. 2 of them are 1 byte outputs. Then we have got 1 2-byte output and 1 8-byte output. In a minute, we will see where to use them. Okay, so of course, it's very important to have the it's very important to have the slots configured in the same way, both on the Adaptive Vision side and on the TIA portal side. Okay, so what data am I exchanging here? First, I'm reading information about the requested inspection type. On this production line, I have got 3 different types. So I would like to get information from my PLC about the current type, because based on that, I will perform the inspection procedure. So then I'm reading information about the trigger. So the PLC is not triggering the camera directly, but rather I'm triggering it once I get information from PLC. Here, in this expression, I'm looking for the rising edge. So only when the trigger value changes from 0 to 1, I would like to trigger a camera. For that triggering, I'm using a queue mechanism. So I'm adding a value to a queue, and later in the main macro filter, I'm reading that value and triggering the camera. Then the third data which I read from the PLC is the expected stripes count. As you will see in a minute, our object comes in 2 shapes, with 5 stripes and 6 stripes. So I'm reading that information, that requirement from PLC, and in this situation, I'm using a global parameter to save that data and transmit and verify the inspection results based on that. Okay, that was the, let's say, incoming messages from the PLC to Adaptive Vision. And now let's see how the outgoing communication looks. Once again, we are utilizing a queue mechanism for reading data from main macro filter and adding it and acquiring that data from the communication worker task. Additionally, I'm using a user type which is called results, because I have to send a four values. So it's much more convenient to combine all these values into one user type, because otherwise we'll have to create a 4 separate queue pop and also queue push on the main macro filter side. So whenever you have got a data which goes together, a user type is a very handy solution. Okay, so I have got 4 data to send, whether the type was okay. So I'm expecting, for example, a type 1, and once I get the information, once my vision system read that on image we have got a type 1, and the number of stripes equals to the requested number of stripes, I'm sending the let's say inspection results using the 8-bit type of data to my PLC. Then I'm sending information to my PLC about the average stripe width. As you can see, before sending, I'm using the expression to change to convert data from a floating point to the integer. The main reason for that is that it's much easier to send an integer value and then on the PLC side once again divide it by 100, then sending a floating point value at once. Another solution, very popular from my point of view, is sending the is dividing the data into, let's say, two values: the value on the left side and the fractional value on the right side, and sending that as a separate on the separate slots. Then I'm sending information to PLC about the outer diameter as well as inner diameter of our circles. In this situation, once again, I'm multiplying it by 1000 to remove the fractional value, but later be able to obtain it on the PLC side. Here I'm also using something which is called a byte buffer for storing data or combining data, and then sending it as a one object using a Hirschler slot write. Finally, I have got something which is called a data ready. Data ready is an information for PLC that all the outputs has been updated, and now the PLC can store this value and use them for some other operations. So I'm setting a data ready bit to 1. I wait 500 milliseconds, but it only depends on your network architecture, and then I'm resetting this value. Okay, once we go through this communication worker task, let's briefly take a look at the main application and start our inspection. As I mentioned before, first we are using a QPOP to read information about the trigger. Then we have got inspection of our objects. And finally, we are sending the results using a QPush mechanism. Okay, I will run the program now. I will take the HMI. Give me a second. Okay. I have got the HMI, and now first I will be sending a triggers from the PLC. As you can see, the indicator that the Profinet online is green, so it means that it is operating correctly. Now, for example, we can change the information on the PLC side that the expected stripes count is 5. And now we'll see that in this case we have got a 5 stripes. I mean these, let's say, mounting elements. In this situation also 5 stripes. But here we have got a fail. So the number of stripes is unequal to the expected number of stripes. Okay, also you can see that currently expected type is 1. But I can switch it to the 2. And now, once I go through the elements, or maybe I will change the stripes, expected stripes count to 6 to get a green results. Okay. In this case, we can see that the recognized type is -1. It means that probably we got a type 1 object. I can define it, or I can verify it using these imprints, these 5 circles here. Okay, in this case, I'm missing the stripes, so we have got here information. And additionally, we are measuring the 2 diameters, the inner diameter and the outer diameter of our object. Okay, let's see how it looks on the PLC side. Now I will take a watch table and I will see what we have got, what parameters do we have here. So first, as you can see, we have got a production time. I'm changing it on the on my PLC, and at the same time it changed on the vision system side, right? You can see it here. Then I will change the expected stripes count. So I'm changing between the 6 stripes and 5 stripes. Finally, I will be sending information, I will be sending triggers, and we can verify the diameters as well as the average stripe width on the PLC side. Right? For example, for now the average stripes width is 1.341, and here we have got exactly the same value. We just have to divide it by 1000. And for example, the next input is the outer diameter, which is 17.135. And here also we have got 17.13, in this case, once again 5. Finally, we have got the inner diameter, and you will see it here. Right? The last input is our get results. We have got a 0, which denominates us that it is incorrect object. And here we have got 1. So it means that our object has been localized correctly. Okay. You can see how it works here. Okay, at that point I will just take a look at the inspection. So I will switch to the offline inspection. I will turn off the HMI because it's not necessary for us at that moment. And I have got the image acquisition. Then I have got the calibration so that we can express our measurements in millimeters, as well as I'm removing the lens distortion here. And then in perform inspection, I have got first a variant macro filter where I select where I have got the inspection routine unique for each object. For example, in this case, I'm using a template matching for object localization using the edges. Right? You can see what edges has been used for this case. Then I'm using a presence checking in the limited ROIS region of interest, so that to verify whether we have got these imprints or not. Finally, basing on the information from these two tools, I'm evaluating whether our resulting type is okay, is consistent with the expected by PLC, and I'm passing the output. Then I'm performing a few measurements. I'm detecting the inner circle. Then I'm rescaling this circle a little bit so that I can measure the width of the stripes. Here I'm detecting the stripes. Maybe I will hide it. You can see it now. Using an expression, I'm evaluating whether the number of stripes is equal to the requested number of stripes, as well as I'm calculating the average width times the word scale. So here I'm converting it to the millimeters. And in the second line or third line of our expression, I'm formatting this value for the HMI. So you can see that the average stripe width is 1.161, and I'm adding the millimeters to that. Finally, I have got the outer diameter detection, and here once again I'm using the fit circle for that. Here I am converting from radius to diameter, and I am multiplying it by inversed word scale so that we have got information in millimeters. Okay, I think that you get the impression how the communication over the Profinet and other protocols inside adaptive vision works. You will see that it is pretty straightforward to implement that. And now we can switch to the questions and answer. And in case of any questions, feel free to ask me now. Okay. Does AVS or Adaptive Vision Studio acts as a Profinet master or slave? I was talking about that during the presentation, and here the master is PLC, and we are connecting as a slave device. Okay. Are these filters to communicate with backhoe PC-based PLC? In fact, as far as I am aware, for backhoe, the standard protocol of communication is EtherCAT. In fact, the EtherCAT is on our development plan after the Ethernet IP. However, I was not mentioning it before because it will be probably at the beginning of the next year, so it will take some time. Is the Hilschler PCI Express card supported? Yes, that's one of the cards one of the Hilschler devices available to use. You can use PCI card. You can use mini PCI card. So it will always depend on your requirements. When exactly will Ethernet IP be available? The Ethernet IP is already implemented, and we are conducting a test. So it should be available, I believe, probably within a month or something like that. So because we are rather finishing implementation of that protocol. Is it possible to send data using Profinet from two different threads, or do we need to use a queue and send data from main communication thread? For now, as you stated in this question, we have to use a queue for that operation. However, now when we are working on the Ethernet IP, we are also improving our Profinet communication, and soon it will be possible to send data from different threads. Only probably the Profinet channel open will be limited to just one thread. However, it will definitely ease the application or ease the inspection. Do you plan to implement OPC UA? In fact, the OPC UA is pretty, or theoretically pretty popular protocol. However, we don't encounter much questions about that So for now, it's not very high on our in our development plan, in our roadmap. However, if you have got some project where you need it, please contact us directly, and we'll probably figure out some solution. Are there any plans to add SQL connectivity? In fact, for now, from my point of view, the SQL connectivity is much easier than handling the Profinet or Ethernet IP directly. We have got an example for the database integration. It's available directly inside Adaptive Vision Studio, and you can use a user filter for that. What exactly database would you like to communicate with? Okay. I think for now it is prepared for the Microsoft Access. However, I remember that we had also some examples for MySQL. Please contact with us after the presentation, and we'll share this example with you. Are any remarks regarding the TCP/IP communication? In fact, the TCP/IP communication is very popular still. We are using it in many different applications. It definitely requires a little bit more. It's a little bit, let's say, maybe not harder to use, but you are responsible for creating the entire let's say communication process. You can work as a server or a client on the Adaptive Vision side. For example, one of the typical use is, for example, exchanging data among the one PC between the different applications. We are using a TCP for that, and it works very well. However, for communication with some other devices, it is of course possible, and it is the only one available option. You can just use it. However, probably you have to take care of the error correction and stuff like that by yourself. If I would to use an embedded hardware, which one could be used? For the embedded devices, you can use a mini PCI card from the Hirschler portfolio, and it should work well. I know that my colleague from the development team was preparing or was working on the Linux integration of the Hirschler devices. So we can probably consult it later. But if you have got a development board, it's pretty straightforward. If you have got a smart camera and you would like to add a Profinet communication to that, at that point, I suggest you using a gateway from the Hirschler company, so that you will communicate with this gateway, and it will send data using the send data over the requested standard of communication. Okay, I think that for now we answer most of the questions. Thank you very much for your attendance. Oh, I see one more question. Yes, the code will be available as an example to Adaptive Vision Studio. If you would like to get it sooner than the official then officially, please contact me and I will share it with you. I was replying to I was 1 second ago I was replying to that question. Okay. Any more questions related to the communication? Then thank you very much and see you on the next presentation.